right, I know you guys are all ready for this, right? Okay, you ready? Ready? All right, class.
Yes.
Oh, wow. Okay, great. Thank you. Okay. Okay, so this is almost a class. This is now study group. Okay, so we are now just going to refer to this as the study group. So, derivative of trigonometric functions. These are some of the easiest things you're ever going to do. Okay, if you know how to draw a circle, this is going to be even easier. Okay, so derivative of sine x is cosine x. Is that easy? Okay, so draw the circle. Let's see. There you go. All right, so I have the circle. Sine x, cosine x. Ready? Derivative of cosine x is negative sine x. Derivative of negative sine x is? Yep. And then the derivative of negative cosine x is? Sine x. Almost like I said it was easy. Because it is. Always. Derivative is always going to go that way. Super easy. If you could remember that, life is easy from this point on. Now, everything else that we use is going to be using those things. Okay? Let's do y prime. This one should be pretty easy. What's the derivative of x? 1, right? Okay. That's 1. Now, plus 4 sine x. Cosine x. That's it. That's super easy?
Yes.
Right? No, that's it. You wouldn't believe that this is, you're doing calculus. It is calculus. Isn't this easier than like all that other algebra crap that you ever did? Yeah. So when I say that calculus is easier than algebra, it's different, and that's what the problem is, where a lot of people can't make the jump. But once you get to this stuff right here, then, oh yeah, we can identify it. Now, for B, question B, what type of rule am I going to have to use there? Product rule, right? Because I have x squared times sine x. So I have 2 of these x's being multiplied together. So if I say that this is my f and this is my g, so insert page, I need some more room to actually do this one. So this is f, this is g. So f prime would be 2x, very good. And we already know what g is, but g prime, cosine x. So if it's product rule, my product rule again is f prime g plus g prime f. So f prime is to x. G is sine x plus g prime, which is cosine x, times f, which is x squared. And I'm going to put the x squared out front here because I don't want to get it confused with the cosine x squared. I don't want to do that. So you want to try and have the variables out front. Your sine and cosine. It's just a good pattern to try and get into so you don't mistake it later on. That's it. Could I factor something? Yeah. I could factor out an x, but that doesn't help me at all. So 2 sine x 2x sine x plus x squared cosine x. C, right here. What rule? Product? Am I dividing? Quotient. Quotient rule. Yeah. So quotient. So I'm going to do that one again. So sine x over x, that's a quotient rule. Okay, this is my f and this is my g. So f prime, what's my f prime going to be? Cosine. And g prime is 1. Very good. All right, and quotient rule again is going to be f prime g minus g prime f over g squared. And all I have to do is plug in here now. So f prime is cosine x times g, which I'm going to put that out front, just like I said on the last problem. So g is my x, right? And minus g prime, which is 1, times f, which is sine, over g squared, which is x squared. Can't really factor anything there, right? Nothing simplifies. Do I just leave it? There we go. X. Huh? Yeah. What's the derivative of e to the x? Thank you. You already did it all. Yes, there is. But there's ln's, which is going to be slightly different. That is log. Okay, that's the opposite function of that. So, but we will have those here in a moment. So, what do we say this one is?
X
Cosine x minus sine x over x squared?
Yep.
Yep. And, oh, hey, look, it's e to the x sine x. That's what you're looking for, right?
Yeah.
Super craziness, right? Okay. Denny, your turn. What rule? Very good. So this is my f and this is my g. So f prime is, thanks Denny, and g prime is cosine x, thank you. Okay, and product again, I will write it out again. So f prime g plus g prime f. So f prime e to the x g, which is sine x plus g prime cosine x f, which is e to the x. So kind of like that last one, I'm going to put the e to the x in front of the sine or cosine. That's always a good habit of getting into. Not behind, put it in front. Yay! It could have been. There you go. All right. Now, by teaching you the circle, did I actually already do this? Do we know what the derivative of cosine is? Negative sine, right? So it's the same thing. We just have to go all the way around the circle. There you go. All right, any of these ones you want to try to do, because it's the same, any of the ones you want to try? Because it's basically the same thing that we just did. We did 4 of them just like this, but this time we're, just doing cosines. Yep. Okay. All right, here's a good one. And I think this is the one I'm going to leave off with today after we're done with this one. Find out points on the graph where that function, where the tangent line is horizontal. Okay, horizontal line, show me horizontal line. Right here, right? What is the slope of a horizontal line? 0, very good. So the slope of a horizontal line is going to be 0. So I know that I'm going to have that f prime of whatever x has to equal 0 somewhere, right? That's important. So tangent line is horizontal. That's what that means. So find out points on the graph where this, okay. So first thing I have to do is, let's find the derivative. So if I have f of x equals x plus sine x, my derivative, f prime of x, would be, yep, 1 plus cosine x. And I know I'm trying to find where all the tangent lines are horizontal. I know that my derivative has to be equal to 0. So I am now going to set this equal to 0. That's important. So I'm trying to get the x by itself, right? So I'm going to start by doing what to this positive 1? Subtract it. So I'm going to get negative 1 is equal to cosine x, right? Now, and I know Denny's got to know this. Okay, it's got to be Denny. If I'm looking for an angle, I do the inverse. I said it for an entire year last year, all year long. If you're looking for an angle, you do the inverse. We're looking for an angle. My angle's in radians here. So I'm going to have to do the inverse here to replace these two items. So now it's going to do x equals inverse cosine of negative 1. So I'm switching these two things. I'm switching these two things right here when I change it to a inverse cosine. Now what that means is, instead of looking at the angle and finding the value for cosine, I am now going to the value of cosine on the edge of the circle. So now imagine your unit circle, okay? Imagine it in your brain. Okay, cosine is the x value, right? Cosine is the x value. I want, where is the x value equal to negative 1? At where? Not 0. At 0, think about it. Isn't that over here on the right? Think of your x values on the right. X values on the right are Okay, positive. Think about it. Over here, so if that's 0, 0, right? The x values going this way are positive, right? So this is going to be positive 1 and 0. Right there, right? Okay, so the x value, so this is a positive and a positive in quadrant 1. Yes? Okay, let's go to quadrant 2. Okay, right up here. At this point right here, my x value is 0. My y value is up 1. Right? Okay, so it's positive y values going over here. So now in quadrant 2, I know that the x values are negative and the y values are up, so that's a positive. So that means over here, negative 1 and 0. Down over here, quadrant 3, I'm going to have a negative and a negative. Over here, this one here is going to be 0 and negative 1. And then quadrant 4, right there. So that means it's to the right. So my x value is positive, but my y value is down below, so it is a negative. Okay, so now imagining this, so now this one is going to be way over here where my cosine, my x value is negative 1. So what was this? What was the angle over here at negative 1? 180, yes, but we're working in radians. Pi, very good, good job. All right, so it is going to be pi. So trying to turn your mind from degrees into radians, okay, it's going to take a little bit of work and a lot of practice to go along with it. So yes, it's going to be pi. That's what we're finding. So we know that when cosine at pi, right, so x equals pi, right? So the x value is negative 1 at pi. Now, isn't sine and cosine a wave? It is a wave, isn't it? Okay, so is it going to keep going? Is it in this wave, every time my cosine gets to pi, it's going to be another time where my tangent line is going to be horizontal, right? That's where it's going to be equal to 0. Okay, so plus, how much do I have to add to get to the same spot again? No, not pi. I got to get to the same spot on the unit circle. So if it's right here, I got to go all the way back around. 2 pi. I got to go 2 pi again, right? And I'm going to keep going 2 pi every single time. Does it say that it ever ends? No. So I'm trying to find all the values where it's going to be there. So I'm going to add 2 pi n, where n refers to how many times I'm going to go around the circle. If I don't go around the circle at all, that n would be 0. And so that would put me right at pi. If I go around the circle 1 time, it's going to be pi plus 2 pi, so that would be here plus all the way around. That's where it would put me. So every time if I'm going back to the same spot on the unit circle, it's going to be plus 2 pi n. Does that make sense or is that nonsense? Might be nonsense. Denny? Bit of nonsense? No? You got this one? Okay. Alrighty. So from here, like I said, I'm going to leave you off here, and then I'm going to let you guys start working on this. Make sure everyone likes, shares, and subscribes. Hit that notification button. Support my channel. Buy stuff for the merch store. Ooh, there is a code on my merch store. Okay, use code.
His phone. His password.
Insert.
Inserting.
Trying to. I'm trying to remember what the code was. I set up a code.
It's on his phone, y'all. Get his phone number.
Use code.
Holiday cringe.
Use code holidays 10. 10% off. There you go. Holidays 10. Get 10% off the merch store.